Hello. In this video, we're going to focus on solving different types of linear inequalities. So if you haven't looked at the video or you don't know how to solve equalities, you'll want to go back and look at that because a lot of the things that were used over there and talked about over there, we're going to talk about with inequalities. So I have this reminder here. Whenever we're dealing with inequalities, it's almost exactly the same as equalities except if I multiply or divide by a negative number, I need to flip the inequality. And basically that's just because if I'm multiplying or dividing by a negative and I'm talking about less than or greater than, I could kind of see these as both talking about the same kinds of things and canceling each other. So if I'm saying it's less than a positive value, then really I could be also talking about it being greater than a negative number. Now, if that quick little talk doesn't help, I do have a link in the guided notes for this module that goes into it a little bit more and talks about it with a little bit of a visual component. But for us, right here, if we just memorize that when we multiply or divide by a negative number, we need to flip the inequality. So just like in the equalities, if I run across any fractions, what I want to do is I want to multiply everything by the denominator to remove it. All right, and so far so good. I have not multiplied or divided by a negative number. So now I'll subtract 7. And I'll divide by negative 5. And again, I'm dividing by a negative, so I need to flip the sign. And if I needed to graph this, or I would have my 14 over 5, and since it's greater than or equal to, color that in and say it's greater than. And if I'm writing this as an interval, 14 over 5 to infinity. Normally, if I'm going to convert something to interval notation, I want to graph it first, just to make sure I have everything going in the correct direction. All right, so the next one. Don't see any issues with fractions, so we'll just get started like before. We're going to distribute. Okay, now I want to get my variable to one side, everything else to the other. So I think this case I will subtract 15u from both sides. And I get negative 8u minus 25 less than negative 9. So now I'll add my 25. Divide by negative 8. And again, since I'm dividing by a negative number, I need to flip my sign. So I could graph it. U is greater than negative 2. And so that means I'm going from negative 2 to infinity. And I could always, if I really wanted to be careful or check to make sure everything I did was right, plug in some values. So I could plug in 0, I could plug in 1, just to make sure that nothing went weird as I was going. All right, this last one that we can see, I'm going to again multiply to get rid of my fraction. Now in this case, we have 6 times 9 over 4. So 54 over 4, minus y. But 54 over 4 could be reduced. Right? We can divide both of them by 2 and get 27 over 2. So now we see we should have also multiplied by 2 because the least common multiple was 12, but that's okay. So now we have this 24 minus 10y is greater than 27 minus 2y. And now it looks just like before. We're going to get the y's on one side, the numbers on the other. So let's say, just for fun and as a contrast to the last one, I'm going to add 10y to both sides. And then I'll subtract 27 to get the 8y by itself. Divide by my 8. Now this might have felt strange for you because normally when we're solving, especially with inequalities, we want to put the variable on the left side, but it really doesn't matter. And in this case, I was able to avoid dividing by a negative number because I moved the y to the right side. But let's see if we can go ahead and still graph it, even though it looks like this. So it's saying negative 3 over 8 is greater than y. Really, we could think about it as y is less than negative 3 over 8. And so we still have that 3 over 8. It's not included. And this says negative 3 over 8 is greater than y. So y is somewhere less than it, which is what flipping this fraction means. And if we wanted to write this in interval notation, we have it from negative infinity to 3 over 8, and it's not included. So you can see with these 3 examples, solving inequalities really isn't that different than solving equalities. The only difference is if we multiply or divide by a negative, we need to flip that inequality. So, compound inequalities. These are basically the same way. In here, we'll normally, if they're split up, solve them separately. So let's go ahead and see what's going on with this one. We have 2x is less than or equal to negative 4. So we solve and get x is less than or equal to negative 2. Now we'll solve the second one by adding 5 and dividing by 2. So now if we graph this, x is less than negative 2 or equal to it, and then x is greater than 3. And so like we talked about in the last video, I like to graph these just to make sure that I don't have any of the special cases going on. We see that it's either or, and these aren't overlapping to graph the entire line. So if I'm writing this in interval notation, I have it from negative infinity to negative 2 and including it. I have 3 to infinity, not including 3. And then because this is an or, I'm saying it's either or, these two combined. So now let's look at this other or option. So we have 4v minus 4. Oh, I could just start solving this. 4v is greater than 20, so v is greater than 5. Three v is less than or equal to 6, so I'll just skip that. V is less than or equal to 2. And so again, if I graph the v is less than or equal to 2, I get this part. If I graph it as greater than 5, I get this. And since it's an OR, I would have both of these. And that's why we like to be careful and make sure we graph it first. I have these two intervals. So the tricky ones, if this had said and rather than or, we wouldn't have had any overlap and there would have been no solution. So in this case, just looking at our graph, if this had said 4v minus 4 greater than 16 and 3v plus 6 is less than or equal to 12, there would have been no solution because and means overlap and there is no overlap. All right, and that's everything we need for solving linear inequalities.